Question 4. An iodine isotope 53I131 decays by emission to an isotope of xenon. State the number of each types of particle in the neutral atom 53I131. So as you can see 53 here, it is atomic number. Z is 53. That means proton number will be 53. And if it is a neutral atom, the electron number will be 53 as well. So 53 here, 53 here. Neutron number, however, is nucleon number 131 minus proton number 53, because this 131 is made up of neutron and proton. Nucleons, basically neutrons and protons are called nucleons. That's why 131 minus 53, which is 78, is going to be the neutron number. Okay. State the symbol of nuclide notation, xenon nucleus. So it has gone through beta minus decay, right? So iodine 53, iodine 131, when it goes through beta minus decay, you see what happens is one neutron gets converted into proton. So proton number increases by 1. Xenon is Xc, and you see the number of nucleon will remain same because a neutron gets converted into proton. It's not neutron coming from outside, okay, which is getting converted into proton. The neutron within the nucleus getting converted into proton. So 131 will remain 131 plus beta minus particle, which is nothing but electron plus antineutrino. Okay. So this is going to be our answer, 54 Xc 131. Okay, that's the answer. Now, the background count of radioactivity in the laboratory is 30 counts per minute. The radioactive sample has half-life of 50 minutes. That means after 50 minutes, the activity or count rate will become half of it, half of the initial value. That means 15. The sample is placed at a fixed distance from a detector. The detector, oh, see, the thing is, this is background count. 30 is background radiation, okay, which is coming from all the objects around the surroundings, okay, in the surroundings. Now, the radioactive sample, however, is having count rate of 310, oh, including background count, it is 310. So what they are trying to say is radioactive sample having half-life of 50 minutes. 50 minutes of half-life, that means the sample will lose its activity by half in 50 minutes. The sample is placed at a fixed distance from the detector. The detector measures initial count rate from the sample. Initial count rate from the sample, including the background count, is 1310 counts per minute. Now, count rate are for only the sample will be 310 minus 30, right? Because this is background count, which will remain same throughout the experiment. So 310 minus 30 is 280 counts per minute. Okay, that's the count rate. Half-life is 50 minutes. Okay. Now, on the figure 10.1, plot suitable points and draw a graph of the count rate from the sample corrected for background. As it changes with time. Okay. So you know one idea you got that half-life is the time taken for samples activity or count rate or mass to be half. Here the count rate will become half. Now you see time is given along x-axis and count rate is given along y-axis. And initially the rate is 280. So every 20 walks, I guess. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 150, 250 we can consider, 250 counts. Then 260, 270, 280. So from here it will start. This is one point, initial point. After 50 minutes, okay, 50 minutes is somewhere here. It will be somewhere here. It will become half of 280. Half of 280, 280 divided by 2, 140. So 140, this is going to be 150, right? Let me write the levels first. This is going to be 50. Now, 140, 40 will be somewhere here. Okay. And 50 is this. So 50. So next point will be here. And after 50 more minutes, that means at 100. Okay. 100. It will become half again. So 280 after half life, it will become 140. And again, after one more half life, that means totally 100 minutes, it will become 70. So 70 will be somewhere 50, 50, 60. This is 70. So here will be another point. Okay, after 50 more minutes, that means 150 somewhere here. This is 150 somewhere here. It will become half again, 150 minutes. After 150 minutes, that means again 50 minutes, 50 more minutes, 50 more minutes. That means after another half life, it will become 35. 35 will lie. So this is 25. This is 25. This is 35. Okay. So this is how the graph. Now join the points. This is how the graph will look like. Okay, exponentially decaying graph. That's it. Now you can find out at any point of time approximately what was the count rate. You can find it out from the graph.